Thank you very much, Johan, for the introduction and for giving me the opportunity to speak to all of you. Good evening from my side. My name is Michael Kohs. I work for HP. I'm focusing on SQL Server and HP infrastructure together. I'm currently in Stockholm because we have just today announced the new parallel data warehouse system version 2 together with Microsoft. So we had a big event at the HP office, and very happy now to have the opportunity to talk about mission-critical SQL Server environments that we from HP offer for SQL Server. So during the next, I hope, 15 minutes, I'm quickly going to introduce what we've been lately doing in terms of hardware improvements, infrastructure improvements, and how that translates into solutions that we think and believe are very capable for mission-critical environments. I'm quickly going to touch on a sample solution for OLTP and a sample solution for data warehousing, and closing with a quick Q&A session. So since I guess many of you don't know all the details about our HP hardware portfolio, I just included this quick overview slide here about our server family. So what you see here on the left-hand side is basically the DL family standard rack mount servers, so x86 rack mount servers. 2 processors, multiple cores, of course, lots of memory in here, so really the standard power horse that most of our customers use. Then we have the Blade family, which we mark here as cloud-ready converged infrastructure, which means we have a great density in terms of computing power. So we can fit 16 Blade servers into this one Blade enclosure, so it's really a great fit for those HPC environments, for the cloud environments. We can automate a lot of the things, provisioning, the network is virtualized in the bladed environment, so it's a great fit for virtualization and cloud environments. We also have the ML family. These are basically smaller tower-based servers, so within their own enclosure. Very good for small offices, remote and branch offices. And then we have the SL family, which are scale-out systems. So they have a lot of internal storage capacity. You can get them in different configurations. For example, 1 node with 60 drives, or 2 nodes with 30 drives each, or 3 nodes with 15 drives each. So really, these are kind of our big data, Hadoop, or also Exchange solutions where you need lots of direct attached storage. So just quickly to set the scene, what we do have in terms of products for the infrastructure. Now, it's very common that with each hardware generation we improve things like performance, reliability, etc. So performance, more memory, you will see that with each generation. There will be newer processors, faster processors, more memory. But what we've been doing lately, especially with our Generation 8, is that we really focused more on the manageability of our platform. So we really put a lot of effort into making it easier to set up the servers, making it easier to manage the servers, and also monitor and update the environment. So in terms of intelligent provisioning, for those of you who've been involved in setting up an HP server previously, we always ship this Smart Start CD with our servers. This is now gone, for example, and all the drivers will be preloaded on the server. So no need for searching drivers anymore, for downloading drivers anymore. Everything is pre-stored on the system already. Of course, that is a faster start for all of these servers. Active Health is all about monitoring. So we analyze over 1,600 system parameters. We will store them on our servers, and we're able to send them back to HP engineers over secured connection. So it's very easy for HP engineers to get a very detailed view about what has happened in the customer environment for the last few weeks. Smart Update is also a great tool, so you can automate your firmware and driver updates, basically. You can define your own baseline, so a baseline that is valid for your environment and your company, and then you can run update checks against this baseline, and all the firmware updates will be downloaded automatically from the HP knowledge base. So when we talk about mission critical x86, in HP terms, this basically means our ProLiant DL980 G7 server, which is our largest scale-up server. So we can have up to 80 cores in this system. So we'll have 8 sockets, 10 cores per socket. We can equip it with up to 4 terabytes of memory at the moment. And with Windows Server 2012 and SQL 2012, we can also use these 4 terabytes of memory, right? Lots of I/O capacity, 16 I/O slots for PCI Express cards. So therefore, we have lots of performance in this DL980 box. But we also have lots of high availability features that we have basically taken out of our Integrity and HPUX product line and put it into our x86 Windows Linux line. So you will especially see this HP Prima architecture, which is HP unique, and you'll only find it in this DL980 G7 server. So this Prima architecture is basically the one special thing about the DL980 that makes it mission critical. So for example, when you think about a system that has 8 sockets, I'm pretty sure you all know what the term NUMA means, so non-unified memory access, that we're using in smaller systems where you have 2 sockets or 4 sockets, where processors are able to access remote memory by contacting the other processors, which works fine for these smaller systems. But imagine having 8 sockets, and each of these processors and cores needs to talk to each other to get remote access to the memory. So that quickly adds a lot of overhead to all these intercommunication stuff that's happening, and therefore it will slow down the system and it will not scale. So you will have an 8-socket system that will not perform well. So therefore it's very important to introduce something like the Prima architecture, which means that we're introducing so-called node controllers, and every time 2 sockets are connected to one node controller, and the node controllers are facilitating the communication between those sockets to have a better access to the memory. So these node controllers will basically cache information about which data is residing in which memory connected to which CPU socket, and therefore the communication is a lot more efficient than by just having each socket contacting each socket. Of course, this needs to be resilient, so we have redundant links between these node controllers, etc. All of these other features that I just talked about in terms of manageability also apply to the DL980, of course. So because of this enhanced availability functionalities that we have and the scalability with these 8 sockets, 80 cores, we typically see the DL980 used for very large databases in OLTP environments, but we also use it for consolidation and virtualization. So consolidation of databases, virtualization of basically everything. And of course, very resource-intensive applications. To give you an example, what we're able to do with a DL980, this is a test that we ran. We used one DL980. We used 10 smart array controllers and additional disk enclosures, HP D2700 disk enclosures. Had a 3 terabyte data warehouse spread across 500 disks attached to the DL980, and we were able to reach up to 28 gigabytes per second throughput with this machine. So that's a huge number, and the DL980 is basically the only machine who can manage the I/O because it has that many I/O slots and a very good layout in terms of supporting these kind of workloads. So this is performance, and about resiliency, there are different things that we're using in the DL980 to even avoid, for example, your SQL Server cluster having to fail over. Of course, SQL has a lot of great high availability features, especially 2012 now with always on. But I mean, it's even better when the hardware can already correct the errors so that SQL does not need to fail over. So therefore, we have the machine check architecture, which is basically a processor feature of the Intel processors. And we implemented a firmware where we can handle all these errors, the error reports coming from the processor, and we are able to move this up to the operating system and even to the SQL Server database. So I'll show a demo later on about injecting a memory error, an uncorrectable memory error, into a DL980 environment which runs Hyper-V and SQL Server on top of Hyper-V, and we're able to survive this error. Previously, we've just been crashed because it's an uncorrectable memory error. The system will go down and restart. So a few examples of what we're able to do in terms of availability. So for example, you could implement something like memory mirroring, where you really mirror all the data that you have in memory. So you will basically reduce the available memory to the system by half, but increase availability. Half of the memory could fail without having you to restart the system or anything. Memory rank sparing is another option, which means you define one memory DIMM that acts as a spare, and in case the system notices many correctable memory errors, it will start moving those to this spare memory drive. So let's quickly switch to the video. So what we're going to see here, as I said, is a ProLiant DL980. We've got Hyper-V 2012, SQL Server 2012. You'll see during the video this has been done with beta or tab bits, so it's not the final RTM bits that we're using here. So we've got a Hyper-V VM with 10 virtual CPUs that runs SQL Server 2012. Just looking at the task manager, showing currently running task CPU activity, and there's our SQL Server that we're running in this virtual machine. So this is the buffer of SQL Server, and the hardware memory error will be injected in one of these pages. We're using the AdventureWorks database, where the memory error will be injected, and we're executing a SQL query that actually touches the data where we will insert the memory, the error during the execution of the query. So now we have this query running. We'll start a nice tool to insert our memory error. So there we are. So we already get the feedback from the machine check exception environment, so that it has discovered the error. When it will push it up to Windows, Windows will show it in the system log that there has been a memory error, and the SQL query will just continue to run. So no SQL Server error log will show it, but it has successfully recovered. So what it will do, it will reload all the data that was part of this damaged memory section, and will just reload it and use it for the query. So therefore, no impact on a running query, and we just have inserted an uncorrectable memory error that would crash any other system. And we're still up and running with our SQL database. So you see that also the VM will survive it and recover it. So you will see this error pop up at each and every level, VM level, operating system level, and SQL level. So when we talk about mission critical, typically this is one of the parts that many people forget, and that's all about services. If you're running a mission-critical database, you want to make sure that you have the right services for this environment. That's not just a normal break-fix support contract, but really maybe a proactive one where you have standard auditions together with experienced HP technicians who will walk you through your environment, look about firmware, etc. So just make sure the right service level is selected for these environments. And now real quick solution examples that we have with the DL980. First of all, we have a tool called the HP Enterprise SQL Optimizer, which really helps you to optimize SQL running on a DL980, because the DL980 is a bit a more complex system than the smaller system. So there are many things you need to make sure you follow best practices, etc. So this is all done in the Enterprise SQL Optimizer. It's free for our DL980 customers, so you can just download it and have a look at it. It will give you recommendations for various SQL Server settings that we have seen perform best on a DL980. So a sample solution for the DL980 in a mission-critical environment for OLTP is this universal database solution for mission-critical x86. So really targeted for OLTP transaction-centric environments. Therefore, we're using 100% flash storage, violin memory arrays here. And we're able to scale it up to approximately 1 million sustained IOPS with this system. So therefore, that's really the most performance system that we can offer right now, DL980 and 100% flash-based storage. For high availability, what we would do is just use the always-on availability groups, have a synchronous replica in here in the same data center. If required, a third data center, we could have a DR node with asynchronous mirroring basically in the same always-on availability group. An example for a data warehousing environment is the fast-track configuration. So these are reference architectures optimized for throughput, data warehousing workload. Again, a DL980, then we're using 16 of these P2000 storage arrays, have it equipped with lots of memory. 768 is the minimum, and we can expand it to 4 terabytes. We have best practices that are applied to this configuration, so lots of how to set up the data LUNs, how many log LUNs, etc. And we're able to support up to 95 terabytes with this system, and we reach a performance of about 13 gigabytes per second if you follow these guidelines with the DL980. All right, so that was a very, very quick and brief overview of what we're doing in the mission-critical area. Thank you again for letting me present here. Here's some additional links. I'm sure you'll get the presentation afterwards. In case you have any questions, I'll be around the whole evening, so just feel free to stop by. And thank you very much for your attention.